All right, today's case is an iPhone XS Max that has no image, no video, nothing on the display. Now, this case I'm going to do on video because there's more than meets the eye. It's a cautionary tale that sometimes what looks like it might be the problem isn't always the problem. I'm going to take off the screen, disconnect the battery, take off the screen, and then we're going to take a look under the microscope. Now, this phone came to us as, oh my gosh, during a screen change, it came up with no image. Help. And they said that they can see that something is knocked off by the LCD connector. So let's start there under the microscope and see if we can notice what they were talking about. All right, here is the LCD connector. And yeah, that looks like there's been some kind of party in this area. So we're definitely missing a component here. And then we've got some other spots that may be missing something, but those also could be no stuff, or spots that have solder paste, but they were never intended to receive a component, kind of omission spots. So it's hard to tell, but this one here definitely is something knocked off. So our next step is to say, well, that's going to be it, obviously. Let's stick that sucker back on there. But before we do that, let's look up and not only see what's there, but also think about the function of whatever is missing. Okay, so at ZXW, let's take stock. We are going to be looking for definitely the identity of this missing guy. So, so our missing guy then is going to be this here, C5782 is missing. That's definitely missing. And it's a capacitor on a line that says PP1VO display. That sounds like our guess would be that's power for image. But a capacitor doesn't have an inline function. So it's more like a grape. So you can pluck one grape off of a bunch of grapes and not really have any practical effect. You can't really tell, that doesn't suddenly stop being grapes. Now, if you have an inline component, you were to cut the piece of the stem, then you have a bigger problem. So a capacitor in general is something that is unlikely to cause a complete loss of function just by getting knocked off when it's a tiny little capacitor in these areas. So that doesn't really seem to be a good candidate for our why we don't have image. So what else is around? The filter that's missing. So it's definitely missing, but it really bothers me how rounded these pads are. They look like they've been kind of like probed a little bit, but these pads don't look like a knocked off component. Compare these guys up here. The missing cap, that looks like a knocked off component. But even the one next to it has rounded, beaded up pads. They look too professional. And those look like something that was never there to begin with, and no stuff. And that's what's going on here at this filter and at this adjacent spot here. It looks to me like the only thing that was actually knocked off was the capacitor, and that doesn't really explain our problem. So before we just start putting things on here, let's stop and let's think. Now, a lot of times you can get a little bit more detail from the schematic itself, so let's head there next and see if we can kind of understand the role of these things. So to the schematic. Okay, so let's start with the guy that's obviously knocked off. So that's our little missing capacitor. And our little missing capacitor is, it's C5782. So let's understand what does C5782 do first, and then we'll look at the other missing guys. So on the schematic, we can just type in C5782. Now, whenever I show a schematic, everybody bombards me with questions. Where did you get this schematic? And this one was funny because the XS Max schematic, I think pretty much everyone I know got an email one day that said, the iPhone XS Max schematic is available on eBay. Click this link. And there was a guy who was trying to sell the schematic for $100 on eBay. And that was crazy because everyone that works in this industry knows that once a schematic falls off a truck in China, then it becomes distributed all over the world within seconds. So if you are looking for a schematic, you should be able to maybe Google the board number or just look around using regular search tools, and you'll be able to find it. If you can't find a schematic that you're looking for, then it never fell off a truck in China. So there's no real use in, there's no like secret treasure chest of all the schematics that everybody knows about but you. They're all commonly available or not available at all. All right, so let's look up our guy, C5782, and try to get a sense of what's going on here. So C5782 is on this page here with the display flex connector. So this is the connector, and we can kind of stare at the connector and see, all right, I see some power lines, I see some data lines that are all probably important for making image work. But let's look for where is C5782 in specific, and here we see C5782 is indeed a capacitor, and it's a tiny one, a 220 picofarad. That's incredibly small, practically nothing, and it is on a line called PP1VO display. So that sounds like a power line with 1 volt on it that would be required probably for display. Now this guy here, FL5782, is a 0 ohm, and it's drawn as a resistor. So that's something I want to call your attention to. See these filters, FL5783 and 5780? This is FL, so you would think it's a filter, and that is typically the case. But when we look even at the board, we can see that FL5782 is indeed a resistor. So let's look at the actual board, because that guy is still present. So I just want to show you that real quick. Here he is. FL5782 is a 0 ohm resistor, and let's just check to make sure that he's present on the board and has continuity. So I'll wake up my multimeter, and since I'm just testing, hey, are you a wire, I will stick it in continuity mode and just test, hey, are you a wire? He says, yeah, I'm a wire. And do you connect all the way through to the connector? Yes. So we do have an intact line from one side of FL5782 all the way through to the connector. So C5782, he's not our problem. He can be knocked off, and that line isn't going to care. So let's keep looking to see, well, what about the other guys in the area? So let's go back to looking at the microscope, and let's see the other guys. So if we're going to say, I just don't think that guy needs to be there in order to have display, but what about the neighbors? So we're missing his next door neighbor, and we're missing a larger component here, and we're missing this little guy, and we're even missing these, this square guy over here. So let's see if we can look up all of those. So first, let's quickly grab their identification. So who the heck are these guys? All right, so we are also missing C5706, we're missing FL5781, we're missing R5720, and we are missing a chip, U5701, but they all look like they're no stuff pads. Now, I want to also call your attention to when you get too married to ZXW, ZXW does not recognize any no stuff. So if a component was omitted and never placed on the board, that's really common, ZXW just reports it as if it's there. So ZXW is a incomplete. So you need to always, if you can, get the rich data set of the schematic that'll give you lots of clues and help you make lots of connections and do better work. So let's go to the schematic and see if we can see what's up with all of these guys. So we'll find C5706 on the schematic itself. Show yourself. All right, it's also a small capacitor. Now sometimes the schematic would say no stuff. This time it doesn't, so it's a little bit of a troll. I still think that that is a no stuff component. And then we can see our missing guy, FL5781. So that's a filter that's missing. Oh, that should be a big deal, because that would mean that we have a broken line here on PP1V1 display. So that seems like that should be a big deal. But it doesn't look like it was ever there. So this is a little bit of a troll, and that's why I want to do this video. I don't think that any of this section is relevant to why this device doesn't have image, and I'll show you why. Let's look back here. This is the chip that we're missing, U5701. Now let's just try to guess what this chip does. So this chip is simple. It has an in and an out, and it has an enable. So something tells this guy, hey, get busy, and it will take an incoming voltage of 1V26, and it will convert that into a very specific output of 1V1. And this kind of dude is called an LDO, which is one mechanism of converting voltage A to voltage B. But here's this is the sort of richness that I'm talking about on the schematic. So it tells us, hey guy, 1.2 volt LDO, that's this guy. This guy is for the LGC, and I don't know what that means. The LGC, something about one of these display, how the display works. The LGC test chip. Once the normal panel is available, then switch to 1.1 volts. So that kind of is a design note that like, hey, this here is going to be changed, or if it's putting out 1.2 now, later it's going to be 1.1. And now when we see that that whole system appears to be missing on the board, we're looking at a screenshot on the schematic of one day in development when that schematic fell off a truck. We don't know what happened after that. Maybe somebody came through and said, you know what, forget this whole section. We're going to do it a different way. So you have to be careful of this stuff and be aware, and that's what this video is about. So this whole chunk got deleted. So this resistor that's missing, the resistor was always no stuff. And this chip is missing, which means that this output is never generated. The chip isn't there. It can't possibly be generated. And since this output then doesn't have a chip to generate it, shut up. And since this output then can't possibly be generated, then of course it doesn't matter if FL5781 is there or not. So it's not put there. And then, of course, C5706 doesn't matter either. So none of this matters. None of this matters, and it was never put there at all. So that isn't relevant to our problem either. So what does that leave us with? If we look back to our actual board, now we know, okay, we are missing a chip. Now that chip didn't get knocked off. Somebody's probed here, but it's missing because it was never there. So the chip was never there, and this resistor that goes with that chip was never there, and this filter that goes with that chip was never there, and this capacitor that goes with those guys was never there. So never there, it's not knocked off, and it's not part of our problem. The thing that was knocked off doesn't really matter. There's no mechanism where a tiny, teeny, teeny little speck of a capacitor that does barely anything. I mean, think about what picofarad means. Pico is 10 to the 12th of a farad. This is it's a million times less than a microfarad, which is already tiny. So it's basically nothing, dust. So that doesn't have anything to do with our problem. Why do we have no display? And I have, of course, done rule number 1, so I have verified that this screen does work on another XsMax, so it's not part. So we really do have no display. So how are we going to figure out what the problem is? Because the problem is not here. It doesn't have anything to do with this physical damage. Okay, so our next step is we're going to compare the broken iPhone XS Max to this good XS Max. Now, this is a phone that belongs to iPad Rehab Business Manager Sunday. So we have taken apart Sunday's phone just to get these normal diode mode readings, or the normal values on the display lines. And people ask me all the time, like, why do you use an iPhone? For this reason, so that we can take them apart and we can have this information that we need. If we didn't have a known good, it would be really difficult to figure out where the problem is, because it doesn't seem to match the physical damage. So I'm going to show you really quickly the finding here so that we can just save time. But just to know that if you do get a case like a $1,200 phone crosses your desk, then go ahead and take the meaningful diode mode measurements and share them with everybody. You can go to iPadRehab.com, click over to our forum to the It Takes a Village section, and upload your diode mode measurements for the latest and greatest phones. That's what I'm going to do right after this job for the XS Max LCD connector. So for now, let me show you with the multimeter. And I'm going to look under the microscope, and I'm going to show you, this is the good one. So this is the good XS Max that doesn't have anything wrong with it. and we can see that it's also no stuff on our same area. See how it's missing our chip? And we can see in there that's a flat area. There's nothing there in that spot either. So let's go ahead and do our measure of resistance. Rather than actually measuring ohms to ground, since that takes a long time, we're going to infer it by using a diode mode measurement that we use all the time. So that starts with red probe on ground. So I'm going to put the red probe on any ground, like this screw hole. Not the frame, but the board, ground on the board. And then I think the problem is somewhere around here. And over here at the bottom of the connector, we get this 0.5, 0.5 ground, 0.5, 0.5 ground, 0.5, 0.5. So that sort of line, ground, when they're all the same, that's really characteristic of display connectors, and those are the image data lines, and they come in these paired sets, and they're bordered by ground. That's in every iPhone ever. So we know, okay, those are going to be image data, so let's make sure that that's a match on our dead phone. So we're going to check the exact same spot. Where is it? So that area looks good, but let's check. So we're going to do the same thing, red probe on ground, and we should get the same numbers. So, more or less 0.5. Same ground. The same 0.47, 0.47 ground, 0.47. Whoa, what? There's our problem. This should be 0.47, 0.47 ground, but it's not. And two of them, OL, overload or open line, because there's an enormous amount of resistance. It can't pick up that normal diode mode. Now both of these are open line, and so we're missing that sort of pattern where it is data line, data line positive, data line negative, ground, data line positive, data line negative, ground, open line, ground. So that's our problem right there. And since there's two of them that are open, we're probably missing one of those classic little data chokes that sit in line between the connector and all the way back to the CPU. So let's go on a hunt. First, let's confirm that. Let's check on the schematic and make sure that the iPhone XsMax, which I've never seen one before today, whether or not that actually has the same feature that every other iPhone has had. So let's look on the schematic just to be sure. All right, here we are at the schematic, and we can see down on this side, it's exactly like we expected. Data line PN ground, PN ground, PN ground. So these are three of them on one side of the connector, and then two of them on the other side of the connector. So just like every other iPhone. And then on the same page, we can follow these guys, and they go over here to this set of what we call data chokes. So they're like double filters where they keep these two lines together, and it's kind of like a filter built for two. All right, so these have certain data that if we wanted to go order one, we could probably find an exact match for that if we wanted to order one to replace it. So our guess is that we have an open line here on both of these guys because this filter is probably just nudged or knocked or blown. So let's investigate it. So we're going to go on a hunt to see if we can dig it up. We're going to try to kind of excavate it and see, is it actually damaged or is it just lifted off? So that's a pretty good likelihood that that's what's going on with this phone. So let's go check it out on the board. All right, so I'm going to use a little bit of low heat to excavate around this area safely. Let's open up these other connectors first. The beautiful tool that is fantastic for connector work is the human fingernail with its dynamic grace that can sense things like, am I lifting up a filter? Better stop. No better tool than the human fingernail. Not available at iPad Rehab Supply. Let's see. So we can see right now the little characteristic square shape of these data chokes. And then here, Look at that. See that movement? You can see that this filter that's completely hidden, it looks great. That's the problem, that filter right there. You can see that when I went to try to even make a measurement, I have movement. Let's check it out. Let's probe. Hey, buddy. You're not on your pads, are you? No, you're moving around. Stop that. You're not supposed to be doing that. Yeah, so we can see that within the waterproofing, under there, that guy is loose. So let's very gently sneak up on him and dig out that waterproofing. So low hairdryer heat. We're just going to try to free him. We're going to liberate him from the corset of this silicone waterproofing. Okay, he's not okay. He's broken in half. But this is really cool. This is a really cool view of why it is that we say this word filter in our industry. And why do we say that? We say that because these components are in the class of inductors, and inductors all have a coil of wire, but they don't have inductance. They don't function like an inductor coil. When we say coil, we mean an inductor that is a coil of wire that has the feature of inductance. For these guys, we mean filter, which is also a coil of wire, also an inductor, but they're used in the circuit differently. And we can see in this rare unicorn view of this data choke, which is a double filter, we can see the coil of wire. See that? Isn't that cool? He's not okay though. So the iPhone X has a really similar component. We can check that out. We can see that this is a row of the same data chokes, and we can look at those values, and they're really, really close to what's going on here in the XsMax. So compare that to the XsMax, the row of filters. It's a really, really similar component. So we're going to use one from an iPhone X and put it in place here on the XsMax and see if that solves the problem. Okay, so these are not directional, so I can simply take it and I can Control C, Control V over to the XsMax board. And I'm going to place it using the mini hot tweezers. Now I'll know if we actually got him on there because we will now have our normal diode mode readings in the connector. So let's go check on that. Let's check red probe on ground. And now let's go down this connector. 0.4, 0.4, ground, 0.4, 0.4, ground, and now 0.4, 0.4, ground. Huzzah! So that tells us that, yeah, this component is soldered on completely on both sides. All four of its dots are down. We know that because we have restored that normal reading in the connector. So let's clean this up, and the next step is to test to see if it works. Clean up with alcohol, and let's test. All right, everything's connected. Let's see. Show me image. Yay! Love to see that. There we go. Everything is working, and we have touch, and ready to go back to being a beautiful $1,200 iPhone. So there you go. Sometimes You have to use your brain, learn to use the multimeter. The multimeter is king. The multimeter solves more problems than anything else. And I love this case as sort of an example of how to not get trolled, how to not be so hasty that it's not always see broke, fix broke, end of problem. You know, you gotta sometimes do a little measuring. So there you go. If you like what we do on our channel and you want to come and learn how to use the multimeter, how to figure this stuff out, then come check us out at Practical Board Repair School. So we have this May, in a couple of weeks, our masterclass that we're hosting with Phone Kong from China. So they're coming over to teach us how to do all of the advanced stuff, CPU rework, advanced diagnostics. We're so excited about Masterclass, 8-day course. You can find out on iPadRehab.com training. And then if you're a beginner, come to Practical Board Repair School. Our June course is full, but we have spots open for July for a regular short 5-day fundamental course, how to learn how to do what we do. And then if you want to explore our Android option, we have a 7-day course that also teaches you Android chip-off data recovery and some Android signature problems as well. So check out our training options at iPadRehab.com. Click training, read all about it, and we'll see you here at class.